The appearance of the dark mass was first recorded not through direct observation, but through the abrupt collapse of ambient luminosity beneath a region of unusually clear tropical water. The water had, for days, exhibited exceptionally high transparency, with sunlight penetrating to depths seldom reached outside polar regions. This clarity was documented in optical profiles collected by autonomous buoys when, without warning, the measured irradiance dropped sharply across the entire visible spectrum. The decline was so sudden and uniform that it resembled an artificial blackout rather than a natural turbidity event. Sensors placed at depths of 5, 10, 20, and 40 meters all registered the same simultaneous reduction in light intensity, creating a vertical curve so smooth that it suggested a single, massive intervening structure. Divers operating in the region at that time experienced the phenomenon directly. One moment the water shimmered with bright refracted sunlight. The next, the illumination dimmed to a uniform heavy twilight, as though the ocean itself had shifted into eclipse. The darkening was not accompanied by any turbulence or surge. No downward current, no shock wave, no temperature fluctuation indicated the passage of a physical body large enough to obscure sunlight across such a wide area. Instead, the transition occurred silently. The water remained thermally stratified, with no mixing between layers. Acoustic profiles recorded by nearby hydrophones showed no anomalous pressure signatures, no low-frequency emissions, no mechanical intrusions. The mass blocked light, yet exhibited no detectable physical presence in conventional senses. Divers described the sensation as entering a sudden, unnatural dusk. The water became uniformly dim, not in patches or rays, but in a single cohesive field of shadow that extended in all directions. Looking upward, they saw not a silhouette, not an object, but a continuous darkness, a smooth, impenetrable layer of obscurity moving across the surface light boundary with absolute, featureless uniformity. Once the dark mass passed, sunlight returned just as abruptly. There was no gradual brightening, no scattering or shimmer to indicate dispersal of particulate matter. The change resembled a binary switch between light and darkness. The transition lasted less than a minute, but the event was recorded with enough precision to rule out atmospheric causes, drifting clouds, surface disturbances, or planktonic blooms. Analysis of hyperspectral data revealed that the blackout affected all visible wavelengths equally, creating a pure attenuation profile with no spectral tilt. Even at depth, where blue wavelengths typically dominate, the shadow absorbed light in a flat, non-dispersive manner. This indicated that whatever passed above did not filter, scatter, or distort incoming rays, but blocked them entirely, acting as a perfect occluder. Follow-up surveys attempted to locate the source of the shadow by analyzing shadow geometry and faint refraction anomalies along the photic boundary. These analyses indicated an object or region moving beneath the divers at an estimated depth of 30 to 40 meters, corresponding to the depth of maximum shadow uniformity. Yet sonar data showed no mass, no density gradient, no reflective contour in that layer. The water's acoustic properties behaved as though nothing occupied that space. Sonar beams passed through the region without attenuation. Light was blocked, but sound propagated normally. This decoupling of optical and acoustic signatures challenged all known oceanographic models. No documented marine organism, no suspended particulate cloud, no thermal inversion layer, no hydrocarbon plume could selectively block light while remaining acoustically invisible. Further optical measurements revealed another anomaly. During the blackout, the refractive index of the water shifted slightly, causing light rays entering the shadow region to bend with unusual coherence. This bending produced an interference pattern at the edge of the shadow, detectable only by high-resolution equipment. This pattern resembled diffraction around a boundary, not the boundary of a solid object, but of a contiguous volume with sharply defined optical properties. The mass that passed beneath the divers behaved less like an organism or object, and more like a region of altered optical medium, an inversion zone in which light could not propagate normally. The boundaries of this zone were smooth, featureless, and moved coherently, showing no turbulence or fragmentation. Chemical sampling conducted in the minutes after the shadow's passage showed no anomalies in salinity, dissolved gases, or microflora. Water from within the darkened region was indistinguishable from water collected outside. No pigments, particulates, or absorptive compounds appeared in laboratory analysis. If the dark mass had been composed of matter, it left no trace. If it had been an organism, it showed no biological markers. The optical extinction displayed by the mass had no chemical correlates. It was as though the water itself had temporarily changed, state briefly becoming an optically opaque medium without altering its molecular composition. Remote sensing through satellite reflectance data offered additional clues. For a span of several seconds, the ocean surface above the divers exhibited a faint drop in albedo. The surface darkened slightly in a circular region, approximately 100 meters in diameter. This dimming was not caused by surface shading from a cloud or airborne object. Instead, the reflectance dropped from below, as though a subsurface structure absorbed outgoing light, reducing backscatter. This downward absorption contradicted the expected behavior of any known aquatic creature or fluid. Large animals appear as surface ripples or turbulence. Plumes appear as diffuse discoloration. Only a coherent, geometric field with uniform absorption properties could reduce surface reflectance without altering surface texture. As data accumulated, a new hypothesis emerged. The phenomenon was not biological or geophysical in the traditional sense, but represented a transient optical boundary, akin to a lens or wavefront inversion moving through the water. Some researchers speculated that the shadow might have been a coherent thermal or quantum structure sustained by unknown interactions between water density layers and electromagnetic fields. Others suggested an undetected physical object sheathed in a refractive cloak. But these theories contradicted the acoustic transparency. Any object, cloaked or not, would disrupt sonar. Yet sonar showed nothing. Over the next weeks, multiple blackout events were recorded across the region. Each event lasted between 30 and 90 seconds. Each blocked sunlight with absolute uniformity. Each left water chemistry unchanged. Each exhibited the same optical diffraction boundary. The dark masses varied in size, some small enough to cover only a handful of divers, others large enough to blanket entire sections of reef. The most striking feature was their consistency. The blackout always maintained perfect intensity, without flicker, without gradient, without partial transparency. The shadow either was or was not. There was no transitional state. Analysis of movement patterns revealed that these masses traveled along deep thermocline boundaries interfaces where warm and cold water layers met. The masses moved horizontally, maintaining constant depth as though following an invisible contour. They exhibited coherent trajectories independent of currents, ignoring eddies and shear zones. When mapped over time, their paths formed sweeping arcs, reminiscent of migration patterns. But migration implied organisms, and no organism in the ocean possessed the properties observed. The phenomena grew more complex when divers equipped with photometric sensors entered the blackout zones deliberately. Inside the shadow, the darkness was not merely a reduction in sunlight, but an absolute uniformity of illumination, as though all directional light collapsed into a single, flat dimness. Surfaces lost texture. Edges lost contrast. Biological structures became silhouettes. Instruments sensitive to low-frequency electromagnetic fields recorded slight fluctuations, subtle oscillations in the 0.11 Hz band. These fluctuations grew strongest at the center of the shadow, implying that the dark mass possessed an internal structure, invisible but detectable through its disruption of ambient electromagnetic gradients. Eventually, a key detail emerged. The blackout occurred only during certain tidal alignments, specifically when internal waves propagated along the thermocline with sufficient coherence. These waves, invisible to surface observers, carried vast, slow undulations across the boundary between water masses. At specific internal wave frequencies, The dark masses appeared always beneath the crest or trough of these unseen oscillations. This pointed toward a resonance phenomenon rather than a living entity. But the perfect optical opacity contradicted everything known about fluid resonance. No arrangement of water masses, no density oscillation, no thermal inversion could produce a complete, uniform blackout. The final piece of the puzzle surfaced when a deep tethered camera system positioned itself directly beneath a passing dark mass. At the moment the shadow crossed overhead, the camera recorded an impossible phenomenon. The water above did not darken gradually from shading. Instead, the camera's field of view abruptly collapsed into a single plane of darkness, as though the volume of water above had lost its ability to transmit photons entirely. The darkness exhibited no parallax, no relative motion, no surface detail. It was not an object, but a planar optical discontinuity sweeping across space. The dark mass was not a creature, not an object, not a plume, not a fluid anomaly. It was an inversion field, a moving, coherent region where the propagation of light through water was momentarily suppressed. What generated it? What sustained it? Why it moved in stable arcs? No model yet explained. But one fact was certain. As long as internal waves pulsed along the thermocline, the dark masses continued to travel beneath divers, silent, invisible to sonar, perfect in their opacity, leaving no chemical trace behind. A shadow without a source, a boundary without a body, a darkness that moved as though it were alive, yet possessed no substance at all. In the weeks following the initial incidents, the frequency of the dark mass events increased. What had first appeared as isolated blotting episodes became part of a larger pattern, one that began to manifest across a growing radius of open water. The blackout zones, once small and intermittent, now traveled in elongated trajectories that extended for kilometers. Satellite instruments recorded subtle, linear depressions in surface reflectance, moving in smooth arcs that traced the pathways of invisible subsurface structures. These arcs were too coherent to be random, too long-lived to be turbulence, and too perfectly geometric to be produced by biological swarms or migratory aggregations. Internal wave modeling revealed that these arcs followed the propagation crests of large-scale oscillations flowing through the thermocline. Internal waves, normally diffuse and chaotic, now exhibited unprecedented coherence, forming kilometer-long ridges of water density that persisted far longer than typical stratified dynamics allowed. Within these ridges, the dark masses moved like shadows following an unseen underlying lattice. Yet no physical matter could be detected in the region, and no acoustic reflection suggested the presence of any mass greater than planktonic density. Sound passed through the regions effortlessly, as if nothing occupied the space at all. Further attempts to characterize the phenomenon utilized synchronized optical LiDAR bursts fired downward from research aircraft during blackouts. These bursts, calibrated to penetrate water columns with precise energy profiles, vanished completely upon striking the dark mass boundaries. The absorbed photons did not scatter, they did not refract. They simply failed to return. Even the small portion of light normally reflected off microscopic particulates failed to register. It was as though the volume of water inside the shadow had become a light sink, a domain where electromagnetic propagation was inhibited to the point of effective optical extinction. At the same time, pressure transducers tethered deep along the blackout pathways recorded microturbulent signatures inconsistent with the spatial uniformity visible to the eye. Although the water looked uniformly dark, the internal pressure maps revealed oscillating gradients within the shadow. These gradients aligned into rhythmic, wave-like forms, indicating that the darkness possessed an internal structure invisible to both the naked eye and conventional sensors. The oscillations appeared to twist slowly as the shadow moved, forming spirals of compressive energy that rotated with stately precision. These spirals bore striking resemblance to pressure vortices formed in laboratory tanks when water layers of different refractive indices were subjected to rotational shear, except that the oceanic events occurred in complete thermal send. Stability, With no measurable shear forces, the spirals were not driven by physics known at that depth. They were imposed. A breakthrough came when a deep immersion photometric array succeeded in mapping the boundaries of a large blackout mass in ultra-high temporal resolution. What it revealed changed the understanding of the event's nature entirely. The boundary of the dark mass was not simply a sharp gradient between illuminated and non-illuminated water. Instead, the boundary flickered with extremely rapid, low-amplitude oscillations, microscopic pulses, far too fast for unaided observation. These micro-oscillations reduced in amplitude with distance from the boundary, like standing waves collapsing into stillness. Mathematical reconstruction showed that the boundary acted like a propagating interface between two different optical states of water. State 1, normal seawater, transmitting light. State 2, a metastable optical phase in which photons propagated only nanometers before quenching. This second state resembled no known physical fluid phase, but behaved as though water molecules within the region had been temporarily reorganized through an unknown influence, perhaps electromagnetic, perhaps mechanical, perhaps something entirely different, into an alignment that prevented the coherent passage of photons. Yet this alignment left sound unaffected, suggesting that the phenomenon acted selectively on electronic transitions, not mechanical properties. Attempts to reconstruct the energy conditions required to produce such a state revealed impossibly high activation thresholds, far beyond anything the ocean could naturally sustain. Yet the phenomenon occurred without measurable changes in temperature, salinity, or EM flux. This paradox forced researchers to consider the possibility that the transition was not driven by ambient conditions, but by a traveling field, a propagating influence, coupling selectively with water's molecular structure. As events continued, the blackouts began to exhibit new behavior. Instead of merely absorbing sunlight, some shadows began to distort light around their perimeters. Divers reported seeing faint luminous outlines around the edges of the darkness, pale halos where refracted sunlight bent sharply, creating thin arcs similar to optical caustics. These halos moved with the shadow, maintaining their shape and curvature. Their consistency suggested a refractive boundary with lens-like properties. The darkness itself remained perfectly opaque, but the surrounding water bent light in complex patterns, indicating that the inversion zone exerted non-uniform optical gradients. Satellite spectroradiometers detected that during these halo events, a minuscule portion of infrared radiation increased at the shadow's leading edge. This infrared signature did not originate from heat. It exhibited no thermal decay curve. Instead, it appeared as coherent IR banding aligned with the shadow's velocity. This implied that small fractions of absorbed sunlight re-emerged at the boundary, shifted in wavelength, as though the dark mass processed electromagnetic energy before releasing it in diminished form. The phenomenon reached its most puzzling phase when multiple dark masses began appearing simultaneously across large expanses of ocean. These masses moved in synchronized formations, maintaining consistent spacing and parallel trajectories. They did not interact physically, but their optical boundaries fluctuated in unison, suggesting that they were part of a larger system, localized manifestations of a broader, invisible structure permeating the thermocline. When mapped globally, these synchronized paths formed longitudinal corridors, stretching across entire ocean basins. The corridors aligned with deep internal waveguides, massive, slow-moving undulations that circle the world within the ocean's mid-depth layers. The dark masses, it seemed, traced these internal wave highways with astonishing precision, as though following pre-existing pathways laid down by the physics of the world's stratified oceans. But these pathways were merely waves of density, nothing capable of producing light-blocking regions. Here, the most radical interpretation emerged. The ocean's internal wave system might be interacting with something external, something vast, coherent, and normally invisible using the thermocline as a conduit. The blackout masses could represent intersections between the internal wave field and an unknown traveling phenomenon, one that selectively altered the optical state of water where contact occurred. This interpretation gained momentum when researchers discovered faint electromagnetic phase anomalies, slow, global-scale fluctuations in the Schumann resonance frequency occurring simultaneously with the largest blackout events. These fluctuations were far too weak to be of biological origin and too coherent to result from atmospheric noise. Though the connection was tenuous, it suggested that the phenomenon might couple into planetary EM systems weakly, as though brushing across the atmosphere as it moved through the ocean. When the largest blackout ever recorded occurred, stretching nearly a kilometer across multiple satellites captured the full-scale structure. The shadow appeared as a perfect oval of uniform darkness, drifting along a thermocline ridge. Its boundary emitted faint, monochromatic halos. Its interior absorbed all visible light. And yet the sea surface remained untouched, the surface waves undisturbed. Beneath it, divers later confirmed, the water temperature remained unchanged, the currents steady, the chemical composition pristine. It was not alive, not mechanical, not particulate, not electromagnetic in the conventional sense. It was a field, moving with purpose or pattern, but without form or substance. And then, just as patterns became clear, the events began to diminish, first slowly, then rapidly. The synchronized masses thinned out, halo signatures weakened, infrared re-emission faded. The vast corridors of shadow disappeared from the global lattice. Internal wave coherence returned to its chaotic natural state. Within weeks, no new blackout appeared. Within months, the ocean returned to normal optical behavior. Within a year, only the archives remained. But one detail lingered. In every region where the black masses had passed, instruments detected microscopic permanent shifts in the refractive index of seawater, far too small to alter vision, but measurable in controlled conditions. These shifts formed faint lines tracing the paths of the shadows like scars across the thermocline. Even after the phenomenon vanished, the ocean kept its memory. Long after the last blackout passed beneath divers, the ocean still carried the faintest echo of a darkness that had no shape, no body, no substance, only movement. And whatever had moved through those waters, blocking out sunlight with impossible precision, left behind no explanation, no signature, and no return. Only the quiet, unchanging sea. In the months following the disappearance of the blackout phenomena, the ocean regained its apparent clarity, yet instrumentation revealed that something imperceptible to human senses continued to move through the deep layers in the faintest possible form, like an after-image, too weak to manifest visibly, but too persistent to be dismissed as noise, as optical sensors placed across multiple thermocline boundaries detected fluctuations so minute they fell below biological thresholds, yet formed coherent sequences when analyzed statistically, and these sequences corresponded to travel paths identical to those once traced by the dark masses, though now there were no shadows, no attenuation of sunlight, no visible disturbances, only microscopic perturbations in the refractive index that passed silently through the water, as though the blackout events had left behind a secondary mode of propagation operating on scales so subtle that the ocean itself barely registered their passage, and these refractive trails moved with the same deliberate arcs as the original masses following the contours of internal wavefronts sliding through density gradients with impossible stability, unaffected by turbulence, storms, or lunar tides, suggesting that although the optical signature had vanished, the structural influence remained, embedded within the water column like a template, guiding residual disturbances along paths defined by the earlier events, creating a lattice too faint for direct detection, but apparent through its accumulated statistical influence. And as global monitoring arrays refined their algorithms, they began to detect synchronous perturbations across distant basins where the blackout masses had never been observed, indicating that whatever had moved through the water was not localized, but part of a larger phenomenon that spanned multiple oceanic regions, leaving behind a network of subtle alterations, not in chemical composition or temperature or salinity, but in the alignment of water molecules themselves, as though the facents. Blackout fields had induced a long-lasting metastability that allowed the ocean to retain traces of their passage indefinitely, and these traces formed patterns that oscillated slowly with the motion of Earth's rotation shifting. Slightly with equatorial bulges and deep tidal forces, suggesting that the ocean structure had been modified on a planetary scale, albeit so delicately that it required months of continuous data to even reveal its existence. And when researchers mapped these perturbations across time, a larger revelation emerged. The faint refractive signatures moved not randomly, but in cycles, repeating in intervals, corresponding to deep internal wave periods that propagated globally along the Great Thermohaline Circulation, implying that the blackout fields had not simply passed through the water, but had synchronized with the ocean's own internal rhythms, the abyssal heartbeat of the planet. And now, long after the shadows vanished, the ocean still carried a harmonic imprint aligned with those rhythms, as though a foreign oscillatory pattern had merged with Earth's natural deep dynamics, forming a hybrid state. Neither natural nor entirely anomalous, and over time this hybrid oscillation began to weaken, losing coherence, dissipating slowly into the background turbulence until only the faintest vestiges remained detectable near ridges, trenches, other regions where density gradients were strongest, and eventually even these vestiges began to thin, as if whatever influence had propagated through the water was finally dispersing into equilibrium, leaving behind only irreversible, but imperceptibly small structural changes in the optical behavior of the ocean. Yet just before the last measurable perturbation disappeared, a final anomaly occurred. A cluster of sensors deployed in a distant gyre recorded a momentary collapse of light transmission identical in structure to the original blackout events, but lasting less than 1 second and affecting an area no larger than a human hand, an extinction of sunlight so brief and localized that divers would not have noticed it, yet its structure matched perfectly the signature of the early phenomena, implying that a fragment of the inversion field had persisted longer than expected, surviving in a deeply attenuated form until environmental conditions aligned for the briefest instant to allow it to manifest once more, before dissolving permanently. And after that tiny shadow blinked into and out of existence, the ocean returned fully to its ordinary optical behavior, with no further anomalies. And over the following years, no blackout events were recorded, no refractive signatures remained, and the water regained its natural chaos, seemingly erasing all evidence that anything impossible had ever moved through it. Yet instruments preserved the data, a complete record of a phenomenon that altered the medium without altering its matter, a shadow without substance, a traveling opacity that left no mark except in the memory of the ocean itself. And as decades passed, the event became another anomaly in scientific archives, unexplained, unrepeatable, and unreachable, leaving behind nothing but the understanding that water, the most familiar substance on Dafo, Earth, had once hosted a form of darkness, not born of mass or pigment or depth, but of a fleeting change in the nature of light itself, a darkness that traveled with purpose, yet without body, and vanished, leaving no legacy but the knowledge that the ocean still held possibilities far beyond current comprehension. In the decades that followed the disappearance of the blackout trails, the phenomenon gradually receded into the realm of unresolved marine anomalies, overshadowed by newer discoveries and shifting research priorities. Yet deep ocean sensors continued their silent tracking of the abyss, and even though no further large-scale extinction events occurred, there remained sporadic readings so faint that they bordered on the noise floor, but still carried structural coherence beyond anything random. One such occurrence emerged not as a visible shadow, but as a fleeting dip in ambient blue wavelength penetration, recorded simultaneously by multiple autonomous floats, drifting hundreds of kilometers apart. And while each individual reading could have been dismissed as instrument error, the synchronous timing across B. Distant units implied the presence of a propagating disturbance moving in a coherent sweep through the mid-depth layers, and this disturbance lasted only milliseconds, too short to alter the light field perceptibly, but long enough to register a subtle change in the attenuation coefficient of seawater, as if a miniature inversion zone had flashed into existence, then dissolved before stabilizing long enough to block light in the familiar opaque manner. And although these miniature events lacked the dramatic sensory impact of the original black masses, their frequency increased enough to suggest that the ocean still contained dormant mechanisms capable of momentarily shifting into an alternate optical state. And researchers studying long-term thermocline variability began to notice that whenever these micro-events occurred, internal wave propagation underwent minute changes, with the crests shifting slightly in phase, as though the passing disturbance had imparted a transient refractive impulse, affecting density gradients at molecular scales. And although the effect was tiny, it appeared repeatedly across several ocean basins, this forming a pattern linking the micro-extinction flashes with deep structural feedback loops inside the water column, indicating that the inversion phenomenon had not fully vanished, but instead remained distributed in an ultra-weak state. Embedded within the dynamics of the ocean itself, and as global tracking systems grew more sensitive, new correlations emerged between these micro-extinction events and the oscillatory patterns of planetary-scale waves, such as Rossby Kelvin waves, which sweep the oceans with slow rhythmic motions, driven by Earth's rotation, atmospheric coupling, and basin geometry, and the alignment of these global waves with internal wave ridge structures created rare conditions in which refractive microstates briefly manifested like faint echoes of the earlier formations, as though the dark masses that once glided beneath divers had left behind not physical scars, but an enduring tendency for water to organize itself into those forbidden optical patterns whenever forced into specific resonant configurations. And over time, a hypothesis formed, suggesting that the blackout fields were not external anomalies passing through the ocean, but emergent states produced by the ocean itself under conditions of precise stratification alignment driven by deep planetary oscillations. And if those oscillations aligned perfectly, internal water structure might cross a threshold into a phase where photon propagation was suppressed, creating the temporary volume of perfect darkness that had previously been mistaken for a traveling entity. And according to this model, the blackout event, it were in fact manifestations of a rare stratification geometry, an ocean-scale resonance forming, an ephemeral third optical state of seawater, not stable enough to persist, not energetic enough to alter chemistry, yet capable of blocking all light within its boundary, as water molecules aligned in patterns, normally impossible, outside controlled laboratory conditions, and as the decades advanced simulations confirmed that the thermocline could theoretically support such metastable states only under exquisitely exact densities, which depended on a cascade of synchronous factors, including tidal maxima, oscillatory wave phases, and basin-scale thermal anomalies, all of which aligned during the period when the dark masses were observed, and that alignment slowly drifted as the climate system evolved, moving the world away from the precise combination of variables required to trigger the phenomenon, explaining why the blackout events ceased entirely. As the global ocean warmed, diluted, and shifted into different stability regimes, but before the phenomenon faded completely, one final discovery emerged from a long-term archive analysis in which decades of micro-extinction flashes were compiled into a temporal map, revealing a slow drift in their spatial distribution, creating a pattern that circled the planet over 36 years, forming a near-perfect loop that returned to its point of origin. And this loop corresponded not to migratory animals or drifting currents or tectonic plate motion, but to a planetary eigenmode, a deep oscillation of ocean and crust moving together as a coupled system on a time scale far longer than surface weather or climate cycles. And the dark masses, the blackout fields, the microflashes, were all surface visible expressions of that deep oscillation which momentarily reorganized the water in ways that suppressed light, producing the illusion of a passing object, when in reality, the ocean had been revealing an interior rhythm that emerged only when its internal geometry aligned with the hidden cadence of the earth. And as this realization sank in, the phenomenon finally ended its last microflash, registered by a solitary float drifting far from any landmass, lasted less than half a millisecond, after which no sensor recorded any further perturbation, and the ocean returned entirely to its ordinary refractive randomness, leaving behind no more manifestations and no more shadows, only data and the understanding that the sea had once briefly shifted into a state of impossible darkness, revealing the presence of deep processes normally far beyond human perception. And then, just as quietly as they appeared, those processes withdrew back into the hidden rhythms of the planet, never again repeating within the span of human observation. In the plan, centuries that followed the disappearance of the last micro-extinction flash, the oceans settled into familiar patterns of circulation, stratification, and optical behavior, their surface driven by winds and solar heating, their depth shaped by slow planetary rhythms, and the once inexplicable blackout events faded from collective awareness, preserved only in archived measurements that few bothered to examine. And even those records gradually became artifacts of an era when instruments happened by chance to be sensitive enough and the ocean stable enough to reveal a phenomenon born from the rarest alignment of forces. And as global temperatures continued to shift and salinity gradients redistributed themselves, the intricate density layers that once permitted the metastable optical state dissolved into new configurations that no longer supported such delicate inversions, making the deep sea once again a realm governed by ordinary physics, with light penetrating as expected, sound propagating without anomaly, and internal waves moving in chaotic patterns devoid of the coherence required for the sudden emergence of perfect darkness. And eventually, the scientific models that had attempted to explain the blackout fields were abandoned, not because they were disproven, but because conditions under which they could be verified no longer existed. And so the phenomenon that had once blocked sunlight beneath divers traveled through thermoclines and traced invisible routes across basins became a historical curiosity, the kind that emerges once in planetary timescales and then vanishes, leaving behind only a faint, conceptual outline revealing how briefly a world as familiar as the ocean can shift into a state entirely outside human intuition. And in the end, what remained of the blackout events was not the anomaly itself, nor the attempts to interpret, but the quiet acknowledgement that the ocean, the most well-studied environment on Earth, had demonstrated an ability to reorganize itself through processes deeper and more intricate than the observational window of any species, and that the dark masses that once seemed to glide beneath divers were not living entities, nor lost constructs, nor foreign intrusions, but momentary expressions of the planet's own fluid complexity, a transient alignment of water density and wave geometry that allowed a hidden mode of light suppression to manifest for a short time and then disappear forever. And as the last generation of scientists aware of the anomaly retired and their data faded into obscurity, the ocean remained unchanged in its vastness, continuing its cycles unmoved by the memory that it had once produced, a darkness without substance, a perfect inversion of illumination that passed beneath divers and made the sea feel for an instant as though it contained something immense and unknowable. Yet ultimately, it was nothing more than the ocean, revealing for a brief moment that even in its apparent simplicity, it held within it the potential for rare configurations that would never form again within the time span of human civilization. And so the story ended, not with a revelation, but with the return of ordinary light, unbroken, unchallenged, and the knowledge that the darkness had been real, but was now irrevocably gone. absorbed back into the unobserved rhythms of the deep, where it would remain silent, forgotten, and forever beyond reach. For centuries, the blackout events remained nothing more than a vanishing footnote in the annals of marine science, a phenomenon that appeared suddenly, behaved with absolute coherence, and then dissolved into a silence so complete that future generations began to doubt it had ever occurred. Oceanographic models returned to focusing on currents, salinity cycles, and biological dynamics. The deep reverted to its familiar obscurity. And yet, beneath that quiet, the world continued to change slowly, subtly, and according to processes far older than human observation. Long after the last recorded microflash, the great thermohaline circulation weakened as planetary temperatures rose and polar ice retreated. Density gradients shifted into new configurations, altering the stratification that once sustained the extraordinary metastable states. But the ocean, even in transformation, continued to hold within its vast interior the faintest molecular legacy of the blackout era. Not enough to manifest, not enough to be measured, not enough to be noticed by any living creature, only enough to alter the way water refracted sunlight by margins so infinitesimal that they existed on scales larger than atoms but smaller than cells. As millennia passed, humanity's capability to observe the ocean faded. Observational buoys succumbed to corrosion. Satellites failed without replacement. Research institutions disappeared. The accumulated record of the blackout events, once carefully preserved, eroded slowly until only fragments remained in scattered archives. The ocean reclaimed dominance as an opaque frontier. Human eyes, ears, and instruments no longer probed its depths. The last acoustic node went silent. The last photometric recorder floated until its buoyancy failed. When it finally sank, the ocean took back the last tool capable of perceiving even the faintest hint of those long-gone shadows. And with the collapse of observation came the collapse of memory. The blackout events passed fully into myth, then into nothing at all. The ocean continued its slow transformation as climate cycles gave way to planetary shifts. Salinity gradients compressed, temperature stratification flattened. The deep layers warmed until they met the shallower ones in a near homogeneous mass. Internal waves weakened, then vanished entirely. Without stratification, no resonance corridors remained. The great attractors of density that once guided invisible masses across the thermocline dissolved into uniformity. But the planet did not remain static. Over hundreds of thousands of years, Earth entered new climatic extremes. Glaciations returned with far greater scope, locking the oceans beneath kilometer-thick ice sheets that reached into the equatorial zones. Salinity plumes formed beneath the frozen cover, pushing density gradients into regimes unseen since the dawn of the blackout era. Deep beneath the ice, with no sunlight touching its surface, the ocean began to stratify once more, but now in the opposite thermal direction. Warmth from geothermal sources created upward thermal fluxes through the supercooled layers, generating powerful internal waves unlike those seen in the open seas of earlier ages. And although no human remained to measure it, the ocean once again reached the narrow band of conditions capable of supporting metastable optical states. It began not with a shadow there was no sunlight to block, but with a subtle inversion of emissive thermal radiation. Where hydrothermal vents once glowed faintly in infrared fields, the glow suddenly dimmed in smooth, seamless patches. The infrared suppression traveled across the abyss the way the blackout masses once had, gliding along thermocline boundaries created by geothermal gradients beneath the global ice. These new dark zones were invisible in any classical sense. They blocked a wavelength that no surviving creature could perceive, but they existed, coherent as before, drifting through the ocean as the modern analogs to the earlier phenomena. Now there were no divers to witness them, no instruments to record them, no satellites to mark their passage. They drifted beneath ice, unobserved and unremembered. Yet the ocean reacted. Each passage of the infrared inversion altered minute aspects of deep salinity and thermal structure. With enough cycles, these changes compounded into patterns. Not visible, Not audible, but structural. The ocean once again began tracing invisible loops along its density corridors, guided by the resonance between icebound thermal waves and deep pressure gradients. Over centuries, these patterns grew increasingly coherent until the ocean's interior resonated with slow, rhythmic oscillations, each cycle longer than the last, moving with planetary rotation and geothermal fluxes. The phenomenon did not evolve into a repeating blackout. There was no surface light to extinguish. Instead, it took the form of a long wavelength constructive interference of thermal motion, a planetary scale oscillation born from the unique conditions imposed by the icebound era. This oscillation strengthened slowly, gathering coherence across large basins until it traversed the planet's oceans in continuous global loops. Once again, the Earth's deep interior and its ocean entered harmonic alignment. A new cycle of resonance, utterly silent, utterly dark, utterly invisible. When the Ice Age finally ended and the oceans thawed, the thermal resonance decayed. As layers mixed, the patterns diffused back into randomness. The ocean returned to light, noise, and ordinary behavior. Not a single trace of the resonance survived into the new epoch. The metastable states vanished. The conditions that supported them never repeated. And so, as the planet continued its march through deep time, the blackout phenomena born in one era, echoed in another, passed into the same obscurity that had swallowed all past anomalies. The sea rolled over them, indifferent. The world shifted to new configurations, unaware that its waters had once held the rarest of optical impossibilities. The darkness had come and gone. The ocean had revealed and then concealed. The planet had spoken in the only language it knew: structure, resonance, alignment, dissolution. And in the fullness of time, all that remained was the water, endlessly shifting, endlessly moving, endlessly forgetting. As the planet cycled through its long epochs of warming and cooling, the ocean, ever mutable, ever erasing its own history, continued reshaping itself according to the evolving conditions imposed by atmosphere, geology, and the slow migration of continents. The blackout phenomena, both optical and thermal, had vanished entirely from the physical world, leaving no trace discernible by any future observer. Yet in the deeper mechanisms of the Earth, where changes unfolded over millions of years, the ocean's past resonances remained embedded not as structures, but as tendencies, rare configurations toward which the system could drift under extreme conditions, patterns written not in water or chemistry, but in the statistical behavior of fluid dynamics themselves. Across vast stretches of time, the continents rearranged into new supercontinents, colliding and tearing apart, forcing the ocean basins to widen, narrow, and deepen in cycles that reset circulation systems and altered the world's thermodynamic equilibrium again and again. These continental shifts created new trenches, new ridges, new seamount arcs rising from mantle plumes, and with them came new pathways for deep water to flow. Some of these pathways carved through density layers in ways that subtly echoed the ancient routes once traced by the blackout masses, though nothing visible followed them now. They were only potential corridors, invisible in the present, but shaped by the same interplay between temperature gradient and salinity that had once allowed the ocean to slip into that forbidden optical state. As mantle convection waned over millions of years and geological activity slowed, the deep sea grew more stratified, forming immense, stable layers of water, separated by sharp thermocline boundaries that persisted for tens of thousands of years at a time. These layers were colder, denser, and more isolated than any that existed during the blackout era, forming vast, stagnant domains cut off from surface mixing. Within these dark isolation zones, no light penetrated and no currents disturbed the equilibrium, creating an environment where molecular alignments normally random and ephemeral could stabilize into configurations seen nowhere else on the planet. And it was in one such isolation zone, deep beneath a newly formed supercontinent, that the ocean once again entered a rare thermodynamic arrangement. A confluence of geothermal heat from a dying mantle plume, the crushing pressure of a basin sealed off from circulation, and the slow compression of continental mass above produced a precise density spectrum capable of supporting a metastable optical alignment. But unlike the earlier ages, there was no light to suppress, no photonic field to extinguish. The new alignment manifested instead as a mechanism that absorbed not sunlight, but thermal radiation emanating from the crust itself. It effectively created a region of cold, a moving, coherent domain of temperature withdrawal drifting through the abyss. This thermal inversion acted like a shadow of heat rather than light, moving silently across the basin. It left behind no visible trail, but in its wake, the temperature dropped by fractions of a degree, enough to alter the behavior of deep microbial ecosystems that had evolved to survive in absolute dark. The inversion suppressed their chemosynthetic activity, creating narrow, elongated corridors of biological stillness. For thousands of years, these cold shadows drifted, following the deep geological ridges formed by the supercontinent's weight. They traveled with perfect uniformity along isothermal layers, not dispersing with currents, but gliding through the water as though guided by unseen rails. Without light, without life, without observation, these cold regions evolved into structures even more coherent than the original optical inversions. Their boundaries sharpened. Their movements slowed into perfect synchrony with microseismic vibrations transmitted through the continental crust. The ocean itself became a resonant cavity through which these thermal shadows moved like standing waves. Eventually, as continents shifted again and the basin reopened to circulation, the sharp stratification dissolved. Warm water intruded, destabilizing the cold shadows until they fragmented into diffuse patches of slightly anomalous temperature before disappearing entirely. Millions of years more passed. Ice ages surged and faded. Continents broke apart. New oceans formed. The planet continued its cycles until even the deep mantle cooled toward geological stillness. As the sun expanded toward its red giant phase, the oceans began their long retreat into evaporation and loss. Water escaped into the atmosphere, then into space. The oceans shrank into shrinking pockets of brine, then into isolated depressions of hyperheated fluid. In these last pockets, as the ocean neared its end, the water once again underwent new configurations, this time induced by extreme salinity, supercritical temperature, and the stretching of molecular bonds under intense solar flux. For a brief geological moment, the water reached yet another metastable state, not optical, not thermal, but a strange refractive collapse triggered by supercritical transitions. In those final pockets, the fluid took on a uniform, matte opacity with no reflection, absorption, or transmission of visible wavelengths, a terminal echo of the blackout phenomenon, arising not through stratification or resonance, but through pure thermodynamic extremity. It lasted minutes, then seconds, then dissolved as the last drops of water vaporized. After that, the Earth held oceans no more. Its memory of light-blocking fields, thermal shadows, inversion zones, and deep resonances evaporated with the sea. But the phenomenon, its rarity, its emergence, its disappearance, was never about this planet alone. It was an expression of the physics of water, pressure, density, radiation, and planetary cycles. And across the galaxy, among countless worlds hosting oceans of their own, the same laws would one day align again. Somewhere else, under different stars, in a distant epoch, another ocean would reach the precise threshold where light could be halted in mid-water or heat withdrawn into perfect darkness. Another world would form the same impossible shadow, a shadow without substance, moving with the rhythm of the deep, and no one would see it, no one would know. It would pass through water, leave behind a brief echo, and vanish forever into the long cycles of its own planet, just as it had here. And with that, the story of the shadowed sea of the darkness that moved without form finally ends, folded back into the physics that created it, waiting patiently for a new world to repeat what this one could remember only in its water. And only for a moment. Across the unfolding stretches of cosmic time, the phenomenon that had once appeared briefly in Earth's waters continued to arise sporadically in distant oceans across the galaxy, yet without witnesses or recorders. It remained a silent and invisible signature of the universe's deeper fluid mechanics, existing only as transient structures formed in the interplay of gravity, heat, and molecular alignment. On many worlds, these shadows emerged only once in the entire lifespan of their oceans, then vanished without imprint or consequence, and the planets passed through their evolutionary cycles without ever realizing that they had briefly generated a state of matter that defied intuition. But on a small number of planets, conditions became unusually favorable for the phenomenon to recur far more often, allowing the blackout fields to move through their seas with a frequency so rare that the event shaped the long-term evolution of those oceans in ways no living organism or physical structure ever could. One such world orbited a dim orange star in a system devoid of large gas giants and rich in gravitational stability. Its oceans were deep and uniformly saline, heated from below by a web of geothermal conduits, and cooled from above by a dense atmosphere of high molecular weight gases. This combination created a stratification more stable than any on Earth, producing internal waves that persisted across thousands of kilometers with minimal decay. These waves traveled through layers so precisely balanced that even minor perturbations could trigger metastable alignments of water molecules capable of halting the passage of light. As millennia passed, the shadows formed repeatedly, moving through the depths in sweeping arcs that traced the shape of the thermocline like ink drifting along a hidden contour. The ocean adapted subtly to their passage, and the repeated emergence of blackout fields altered local temperature patterns and density gradients, creating long living corridors of cooled water that persisted for centuries before collapsing. These corridors provided scaffolding for subsequent inversions, making future blackout events more stable and frequent. Over time, the planet's oceans became a tapestry of resonant structures in which inversion fields appeared regularly, not as isolated anomalies, but as an integral component of the deep sea's internal dynamics. While the blackout fields never achieved permanence, they behaved like recurring geological cycles, appearing predictably whenever planetary heat flow, tidal stress, atmospheric pressure, and stratification entered their narrow window of alignment. As the planet aged, the frequency of these events increased and a form of feedback emerged in which the shadow fields influenced the very conditions required for their formation. The repeated suppression of light created temperature sinks, which strengthened the internal wave system, and the strengthened wave system, in turn, enhanced the spatial coherence needed for the fields to form. The phenomenon became a mutually reinforcing cycle that persisted until the planet entered the later stages of its climatic evolution. Eventually, as the star aged and began to emit stronger radiation, the upper layers of the ocean warmed and expanded, while the deeper layers cooled further under the unchanging geothermal flux. This created a more extreme stratification that pushed the ocean into an even narrower band of stability. The blackout fields grew sharper, more stable, and more frequent. They traveled not only through the thermocline, but began to appear in deeper waters, where pressure and temperature created new metastable optical phases that had no equivalent anywhere else in the galaxy. At their peak, the shadow fields existed continuously across the deepest basins, drifting in endless loops guided by the shape of the sea floor. They moved without turbulence, sound, heat, or chemical disturbance, forming perfect volumes of optical extinction that glided silently through the dark. Although no life evolved with the capacity to perceive them, their influence shaped the evolution of deep ecosystems. Organisms adapted to the thermal patterns created by the blackout fields, forming species that thrived in the elongated cold corridors left behind by the moving inversion zones. Across millions of years, these species spread through the abyss, forming vast but fragile chains of life that depended indirectly on the periodic suppression of radiation in the upper layers and the creation of stable deep cold pockets. Eventually, the stratification that sustained the blackout cycles began to erode, Continental drift altered the shape of the ocean basins, atmospheric composition changed as volcanic emissions shifted, and geothermal heat weakened as the planet's core cooled. Internal waves lost coherence, and the precise density differentials needed for the inversion phenomenon dissolved. The blackout fields appeared less frequently, then sporadically, then finally stopped altogether. Their disappearance triggered the collapse of the ecosystems built upon their lingering temperature structures. The deep, cold corridors warmed and mixed, and life that once depended on them faded away. The oceans became ordinary once more, subject only to simple thermal layering and common fluid dynamics devoid of the rare conditions that had once allowed them to manifest impossible states of water. Many millions of years later, the oceans evaporated entirely as the orange star expanded into a red giant, and the last remnants of the blackout fields ceased to exist. Yet in another distant region of the galaxy, new stars formed, new worlds cooled, and new oceans condensed, each with its own thermodynamic potential, its own patterns of stratification, and its own rare chance to create the metastable optical. States capable of producing perfect moving darkness. The universe as a whole remained indifferent, but the physics remained immutable, and on any world where pressure and heat and density aligned precisely, a shadow without mass would form again. It would drift silently beneath an alien sun, extinguishing light without substance or shape, then disappear into the cycles of that world, leaving behind no evidence, no memory, no trace, except the unchanging truth that in the vastness of cosmic possibilities, the oceans of countless planets can briefly host a darkness as perfect and fleeting as the alignment that created it. Across cosmic epochs, the phenomenon continued to arise in scattered oceans across the galaxy, not as a pattern with continuity, but as an emergent behavior woven into the universal properties of liquid matter under pressure. Worlds with water naturally cycled through the states, required to support the metastable inversions, and although occurrences were rare, they were inevitable on a long enough timeline. Yet there existed a deeper layer of this process that unfolded over scales far larger than a single world or system. Whenever a blackout field formed, even briefly, whether optical, thermal, or supercritical, its emergence altered the microscopic configuration of water molecules in ways imperceptible in the moment, but significant when accumulated across millions of years. These changes never persisted in the fluid for long, but they did propagate subtly through the system before dissipating, creating fleeting harmonies between molecular bond angles, hydrogen networks, and local electromagnetic plane fluctuations. On each world, these harmonies existed only for seconds or minutes, but they left behind faint energetic shifts in the water's quantum state that moved outward with internal waves and became imprinted in the thermodynamic memory of the ocean. Although these imprints faded quickly, they contributed incrementally to the statistical behavior of the ocean over geological time. On a planetary scale, the effect was negligible, but the universe contained not one world with oceans, but countless others, each generating its own transient inversions and tiny energetic signatures. Over billions of years, the sum of these micro-signatures propagated through interstellar space as weak electromagnetic drift stored in the radiation background and in the matter fields connecting stellar systems. In most galaxies, this drift passed unnoticed, blending into the haze of cosmic fluctuations left over from earlier cosmic epochs. But in a minority of galaxies, where star formation remained unusually stable for long spans of time, these drifting faint harmonics accumulated within dense molecular clouds. The clouds acted as vast reservoirs where the subtle electromagnetic residuals originating from blackout fields mingled with the raw ingredients of new planetary systems. In these clouds, when atoms collided, bonded, condensed, and fragmented, the tiny energetic residues from countless oceans subtly influenced the angular momentum of dust grains and the polarity of emerging molecular structures. The effect was infinitesimal at first, yet over millions of years it compounded and created regions where the formation of water-bearing planets became slightly more probable than random chance would predict. In these regions, the earliest oceans formed with slightly skewed distributions of isotopes, salts, and thermal properties, creating an increased likelihood that their stratification would eventually fall into the narrow stability band. necessary for the inversion phenomena. Thus, although the blackout fields originated as isolated events, biologically irrelevant, fleeting, and unrecorded, they seeded ever so slowly the preconditions for future oceans to replicate the phenomenon more easily. On a cosmic scale, this produced a form of self-reinforcing cycle, where the existence of rare fluid states increased the future probability of those same states reappearing elsewhere. Not because any memory persisted, but because the physical conditions that supported those states were subtly favored as a second-order effect in the formation of new worlds. Over billions of years, a small yet significant number of star-forming regions began producing an unusually high density of ocean-covered planets. Some of these planets never reached the necessary configuration for metastable inversions. Others did so briefly, then drifted away. But a handful entered long epochs of fluid stability where the blackout fields manifested repeatedly, shaping ocean dynamics over millions of years. These worlds evolved oceans with complexities far exceeding anything Earth had possessed. And in these oceans, phenomena arose that went far beyond simple extinction of light. Some formed supercoherent inversion zones, where the suppression of photon propagation expanded to multiple wavelengths, including infrared, ultraviolet, and occasionally higher frequencies. Others developed complex thermal lattices, where inversion fields interacted with geothermal plumes, creating long-lived pockets of negative radiative flux that drifted like silent storms across the abyssal plains. Still others entered periods where entropy gradients sharpened so dramatically that the oceans behaved like massive resonant cavities, producing vast standing wave fields, visible only as suppressed illumination bands stretching for hundreds of kilometers in geometrically perfect arcs. These planets experienced entire epochs where inversion fields became a dominant component of oceanic cycles, altering climate circulation, deep-sea ecology, and in rare cases even tectonic behavior through the subtle long-term redistribution of thermal energy. Over extended periods of cooling, these oceans eventually fell out of resonance and the phenomena faded. But the electromagnetic drift seeded by them continued to travel outward into the galaxy, carried along by stellar winds and interstellar currents joining the background web of signals that influenced future molecular clouds. Over aeons, the cycle repeated. Across vast distances, worlds that never knew one another were linked only through the shared physics of their oceans, producing a grand invisible tapestry of fluid states appearing and disappearing in patterns too large for any observer to perceive. The universe itself evolved as a system where every transient inversion contributed to the deeper statistical landscape from which new worlds emerged. Nothing intelligent guided it, nothing remembered, nothing carried intention. It was simply the quiet machinery of physics repeating itself across uncountable worlds. As more time passed, entire stellar generations lived and died. Galaxies collided, interstellar matter mixed and redistributed itself across enormous volumes. The signals dissipated, reformed, and dissipated again in endless cycles. Yet always, as long as water existed under gravitational pressure, the possibility remained that oceans somewhere would again slip into the narrow corridor of conditions that produced perfect traveling darkness. Eventually, the expansion of the universe stretched galaxies apart until many drifted beyond any causal contact. In these isolated island universes, new stars still formed, and new planets cooled, and oceans appeared. Yet the faint interstellar harmonics that once guided the formation of water-bearing worlds could no longer propagate between galaxies. Still, the phenomenon persisted in isolated pockets because once seated in enough regions, it no longer required cross-galactic reinforcement. The physics was now statistically inevitable, and so even in isolation, the blackout fields continued to arise sporadically. When the expansion deepened further and starlight dimmed, as the cosmos drifted toward thermal exhaustion, the last generation of water worlds formed around red dwarf stars with long, stable lifespans. These planets hosted oceans under dim skies and low-energy fluxes, but even in their cold, dim waters, inversion fields appeared now and then, rising and fading like ghosts in the abyss. Long after these planets cooled and froze, long after their stars dimmed into the darkness, Long after the universe approached thermal equilibrium, the memory of the blackout fields survived only as a tendency embedded in the deep structure of physical laws. Eventually, entropy consumed all gradients, and no oceans remained anywhere. But in the final cooling of the cosmos, the equations that once governed metastable inversion states still existed, etched permanently into the nature of matter, long after the matter capable of expressing them was gone. Nothing could create another shadow, because no light, no water, no heat remained. But the possibility itself, the structural capacity for blackout phenomena, remained intact forever as one of the infinite dormant potentials of physical reality. Never to be realized again, yet never erased. This was the final legacy of the shadowed seas that once drifted beneath distant suns, a phenomenon that existed briefly in the lifespan of water, then passed into the silent permanence of universal law. Then, as the universe slipped deeper into its final cooling stages, the imprint of the blackout phenomena persisted as an abstract potential, a silent configuration embedded in the governing relations between energy, matter, and space-time. Temperature gradients diminished across cosmic filaments, stars dwindled, and the last pockets of fusion faded into inert cinders drifting across a void that no longer generated complexity at any meaningful scale. Galaxies, which had once blazed with light and motion, now consisted of sparse clusters of brown dwarfs, degenerate remnants, and cold planets wandering through darkness. The temperature of the cosmic background fell so close to absolute zero that thermal fluctuations grew rarer than molecular collisions once had been in the densest oceans. Yet systems still moved slowly along vast trajectories dictated by gravity, even as gravitational wells themselves decayed through evaporation and entropy. In these late eras, matter flowed into an ever more dilute haze, and the structures that once hosted oceans were reduced to silent frozen spheres, drifting through a universe without starlight. Any planet that had once held water now retained only ice, locked into crystalline lattices so rigid that molecular vibrations ceased almost entirely. All the oceans that had once supported blackout inversions lay buried beneath kilometers of inert frost. And although the inversion phenomenon could no longer emerge without mobility, heat, and photonic flux, its underlying possibility remained encoded in the microscopic bond angles of the water molecules suspended in ancient ice fields. These molecules no longer moved as fluids, but their atomic structure retained the same capacity for altered optical states, even if no energy existed to induce them. As more aeons passed, entropy grew so pervasive that even chemical bonds began to fail. Once stable molecules broke apart under the influence of quantum tunneling events that occurred more frequently than interactions between particles. Water disintegrated into hydrogen and oxygen, which themselves decayed into constituent particles, drifting through an expanding universe whose curvature flattened toward perfect uniformity. Eventually, even stable baryonic matter began to dissolve into lightweight particles, incapable of forming anything dense enough to host complex physical phenomena. Still, the equations that once governed the metastable states of water persisted in the structure of the vacuum itself. They did not vanish because they were not artifacts of any particular epoch, but natural consequences of the way forces shaped interactions when certain pressures and energy densities aligned. Even as those conditions became impossible to realize, the laws remained perfect and unchanging. They existed in the deep blueprint of the cosmos, the same way that extinct biological forms remain encoded in the fossil record long after the organisms themselves disappear. In the final stages of cosmic evolution, when matter had become an ultra-sparse mist of disassociated particles and black hole evaporation filled the void with faint whisper-like radiation, the universe entered a state where spatial curvature stretched toward triviality. No gradients remained on which metastable optical states could arise. No oceans, no waves, no stratification could survive this late stage. The cosmos became a simple arena where the only energy came from the final quantum evaporations of massive objects, and these emissions were too weak to alter the character of the vacuum. Yet, the faint harmonic traces, seeded by trillions of blackout events across eons, lingered within the cosmic background radiation. These traces did not produce patterns or structure, but they subtly influenced the statistical distribution of fluctuations across vast expanses of almost perfect darkness. The influence was so slight that no observer could have detected it even when the universe was still young. But in the final cosmic dissolutions, every remnant signal was amplified by the sheer emptiness of the void. The background became an archive of everything that had once been, and within that archive, a ghost of the blackout's harmonic fingerprint remained. It did not shape anything further. It did not propagate into new forms. It simply existed as one final echo of a phenomenon that had once suppressed light beneath alien seas. When the last long wavelength remnants of cosmic microwave radiation stretched so far that their energy approached zero, the universe crossed into a state where no event could change anything further. Processes ceased. Motion became abstract. Time itself lost meaningful differentiation because nothing occurred to distinguish one moment from the next. Yet even in that absolute stillness, the potential for the blackout phenomenon remained embedded in the mathematical architecture that defined all interactions. If the universe were ever to collapse or reconfigure itself into a new cosmic cycle, if matter were to condense again into dense clouds capable of forming stars, if planets once more collected oceans on their surfaces, then the phenomenon would become possible again. Should gravity reverse its expansion and draw matter back together, the seeds would still exist within the underlying physics. The blackout fields would rise again wherever fluid stratification reached the narrow nexus required for inverted optical propagation. Their appearance would not be a memory, but an inevitability, because the laws that allowed them to exist were timeless. Thus, across the totality of cosmic existence, from its bright, energetic youth to its cold, dissipated end, the blackout fields persisted as a potential, dormant shadow awaiting the reappearance of oceans. If the universe ever folded into itself and ignited a new cycle with new stars and worlds, the physics would be the same, and on some of those worlds, new oceans would form under the gravity of new suns. New internal waves would rise from geothermal gradients. New stratifications would develop, and at some precise alignment of conditions, a perfect darkness would again sweep through the water, extinguishing light without blocking it and gliding in complete silence through the liquid depths. Even if no consciousness ever witnessed the event, even if no instrument recorded it, even if the universe repeated its cycles endlessly without memory, the blackout phenomenon would recur, because it was not a story, nor a coincidence, nor an prescient anomaly. It was an expression of the cosmos itself. The universe might end or restart, but the possibility remained immutable. In any world where matter cooled into oceans and gravity stratified their layers, the conditions could arise. And when they did, the darkness would return, for however brief, an instant drifting through the deep, as it had countless times before, gliding silently through alien waters, leaving behind no lasting trace except the continuation of a pattern. Embedded in the fabric of reality, a phenomenon that needed no mind to observe it and no history to sustain it, because it belonged not to life, not to planets, not even to time, but to the structure of existence itself. Even after the universe entered its terminal stillness, when no gradients remained, and no change could unfold across the vastness of space-time, the underlying mathematical potentials of reality did not decay. They persisted beneath the frozen quiet the way dormant seeds persist beneath ash and dust in a dead forest, holding within them the pure geometry of future possibility, even when conditions for growth no longer exist. The laws that had once governed oceans and inversions and light extinction existed outside the rise and fall of planets. They endured even when planets themselves had become an impossible luxury. Across inconceivable spans of time, the universe approached absolute symmetry. Temperature differences vanished. Particles drifted in near-perfect uniformity. Curvature flattened as mass diluted into the unbounded dark. This era, sometimes called the Cold Eternity, was not marked by silence or emptiness, but by a pure equilibrium, so complete that no event could create a future distinguishable from its past. Yet even here something remained, Not active, not dynamic, not actualized, but inherent. The universe still carried the architecture through which all earlier phenomena had once emerged. At this stage, matter existed only as sparse remnants separated by cosmic distances, expanding far faster than any interaction could bridge. The rare particles that still remained occasionally collided in low-energy encounters, producing no heat and no structure. But even these collisions carried within them the rules that once shaped molecules, fluids, oceans, and inversion fields. If one examined the interactions at the most abstract level, stripped of all environmental context, they still reflected the same mathematical symmetries that had governed blackout formations in ancient seas. The forms were latent and unused, but they existed in the underlying logic of the cosmos, woven permanently into the relationships between fields, constants, and forces. Eventually, even particles themselves decayed. Protons dissolved through quantum tunneling processes so slow that they unfolded over timescales beyond any earlier cosmic epoch. As matter unraveled, the universe transitioned from a realm of particles to a realm dominated entirely by radiation and virtual fluctuations. These fluctuations, though too faint to support any structure, contained within them the last echoes of all physical possibilities. The potential for oceans and water and metastable states remained encoded in the vacuum, in the same way musical harmonics remain theoretically possible, even after every instrument has turned to dust. As the cosmological horizon expanded and the observable universe shrank to a tiny island of fading radiation, the vacuum approached an asymptotic state of minimal energy. In that deep equilibrium, quantum fluctuations became the only remaining activity. They flickered in and out of existence, producing ephemeral pairs of particles and antiparticles that annihilated instantly. For brief instants, these fluctuations produced mathematical conditions equivalent to the earliest foundations of structure. Although no temperature, pressure, or gravity existed at scales capable of forming oceans, the equations governing the metastable optical inversions were still preserved within these momentary dynamics. They were like the outlines of a painting long since erased but faintly visible in the imprint left on the canvas. There came a time when even quantum fluctuations approached near stillness, when the entropy of the universe approached its maximum and all distinctions between regions vanished. This was the far edge of time, a condition beyond change, beyond interaction, beyond differentiation. Only the vacuum remained, a silent expanse defined not by objects, but by possibility. And yet even here, possibility was never extinguished. The rules that once governed light interactions with layered fluids still formed part of the deepest scaffold of physical law. They could not vanish because they were not emergent properties of oceans, but consequences of the geometry of fields and the behavior of energy in confined systems. These rules waited without waiting, persisted without purpose, existed without context. If the universe were to remain in this state forever, then the blackout phenomenon would sleep eternally as an unrealized pattern. But cosmology at the ultimate horizon contained one more transformation. The deep vacuum, with its minimal but non-zero energy density, carried within it the instability required for rebirth. Over infinite eons, the vacuum could spontaneously fluctuate into new expansion events. These events would produce new space-time bubbles, infant universes detached from the old one, each with its own physical constants, initial conditions, and unfolding processes. When such a fluctuation occurred, it triggered the formation of a new cosmos, expanding from a seed smaller than a particle into a young universe blazing with energy. As matter condensed out of primordial fields, new stars emerged, new dust clouds formed, new molecules assembled, and eventually, on some worlds in that newborn universe, oceans would appear again. Gravity would pull water into basins, pressure and heat would stratify liquid layers, internal waves would rise from geothermal stirring. All the conditions that had once existed in ancient seas would form anew. And because the laws governing metastable inversions remained encoded in the fabric of this new spacetime, the blackout phenomenon would become possible again, not as a copy of the old universe, not as a repetition of past events, but as a natural outcome of the same underlying principles manifesting in new circumstances. Eventually, one world in this new universe would develop the exact alignment of temperature, density, pressure, and optical characteristics necessary for a volume of water to slip into a state where photons could not propagate. When that moment arrived, a familiar darkness would rise through the ocean, moving silently beneath the waves, extinguishing light without form or mass. No one might witness it, no system might record it. But it would appear because the universe allowed it, because the laws of existence made it inevitable whenever an ocean reached that narrow balance point. Thus, the blackout fields were not confined to a single timeline or cosmos. They were not an anomaly of one planet's past, but an eternal recurring expression of the physics that govern all liquid systems capable of supporting stratified complexity. In every universe that formed from the ashes of a previous one, the same potential would remain, waiting for the right moment, the right gradients, the right geometry. In this way, the shadow that once drifted beneath divers on a distant blue planet became part of something far greater than any ocean or star. It became a pattern that transcended universes, emerging wherever conditions aligned and vanishing whenever they dissolved. Across unending cycles of cosmic birth and decay, the blackout phenomenon stood as one of the countless quiet truths woven into the structure of all things. A reminder that even in the deepest darkness of creation, new oceans could rise, new light could fall, and new shadows could glide beneath them in silent perfection. Across the unfolding layers of the newborn universe, the early plasma cooled into matter, and the first atoms formed in a haze of expanding radiation. Gravity sculpted these atoms into clouds and filaments until the primordial structures of galaxies began to emerge. In the quiet spaces between these filaments, the same timeless laws that governed all possible interactions waited to be expressed. Nothing in this new reality remembered the oceans of the previous cosmos, yet everything that had once made those oceans possible was woven into the constants and fields shaping the physics of this reborn expanse. As the first stars ignited, they burned with a brilliance far sharper than any that would follow, flooding the young universe with ultraviolet light and creating pockets of ionized hydrogen that expanded like shells through the void. In these early galaxies, heavy elements began to form within the hearts of stars. Iron, carbon, oxygen, silicon, all emerged through the slow alchemy of fusion. When the earliest massive stars collapsed into supernovae, they scattered these elements into the surrounding space, enriching the nebulae that would later give birth to planets. The building blocks for oceans drifted once more through stellar nurseries, forming icy grains and molecular water bound to dust particles. These grains collided and fused into planetesimals, and the planetesimals accumulated into young worlds. Their surfaces were molten at first, their atmospheres thick with vapor. But as the years passed and heat radiated away into the expanding void, these worlds cooled enough for water to condense. Rain fell across entire hemispheres for centuries at a time, filling basins, carving channels, and pooling into the first oceans of the new universe. These newborn seas glistened under unfamiliar constellations, their waves stirred by winds driven by alien suns. Yet despite their differences from the ancient waters of the previous cosmos, they obeyed the same fundamental rules. They stratified under gravity into layers of distinct temperatures and densities. They circulated with currents driven by rotation and heat flow. They developed thermoclines, where stable boundaries separated warm surface waters from colder abyssal layers. These conditions, universal and unchanging, set the stage for the reemergence of the metastable inversion fields. Most oceans remained too turbulent, too young, too chaotic. Their internal waves broke apart before coherence could form. Their stratification was uneven, their geothermal activity too erratic. But on a handful of worlds where tectonic patterns were gentle and planetary rotation slow, thermal gradients formed with remarkable precision. In these rare seas, internal waves began to propagate with increasing stability. They traveled across basins in long, sweeping arcs, retaining their structure over thousands of kilometers. As the waves strengthened their oscillations, they formed temporary corridors of density alignment paths through the water where molecular motion synchronized with surprising uniformity. These corridors drifted along the thermocline, their boundaries assembling and dissolving with a rhythm set by the deep heartbeat of the planet. With every cycle, the water molecules were nudged closer to the precise geometry that allowed metastable optical states to form. And then, at last, the moment came. In an ocean bathed in faint orange light from a dim star, a single volume of water entered that narrow band of alignment where photon propagation collapsed. Light reaching the region vanished completely, not dimmed, not scattered, not absorbed by any material. It ceased to exist within that volume, swallowed by the inversion field that had formed spontaneously within the fluid. The darkness moved through the sea in a perfectly smooth wave, tracing the contours of the thermocline exactly as it had once done countless universes earlier. No life existed to witness it. No instrument existed to record it. But for a brief moment, the blackout phenomenon manifested again, proving that the deep structure of reality had remained consistent across cosmic rebirth. The sea glided in smooth harmonic motion around it as the shadow drifted along its path, unaffected by turbulence or matter, guided solely by the geometry of the stratified fluid. More worlds followed. As galaxies matured and more oceans appeared, the phenomenon re-emerged in other places, each manifestation born independently of all others, yet each following the same principles. On some planets, it appeared rarely, flickering for seconds across a thermocline boundary before dissolving. On others, it became part of recurring oceanic cycles, appearing seasonally or during tectonic shifts. The blackout fields became a quiet background phenomenon of the new universe, seeded not by memory, but by inevitability. And over time, as complexity grew and life emerged in scattered oceans across distant worlds, some of these life forms evolved senses capable of detecting subtle changes in light and pressure. Eventually on one world, deep within a calm tropical sea, a creature drifted through its environment during a moment when a blackout field passed beneath the surface. For the first time since the previous cosmos, a living being perceived the phenomenon. It did not understand the event. It did not analyze it. It only reacted to the sudden, perfect loss of illumination that cut through the water like a drifting night. That creature's lineage would persist. Some descendants would evolve rudimentary pattern awareness. Others would become sensitive to electromagnetic fluctuations. A few lineages millions of years later would develop curiosity. Some of those curious beings would begin to map their oceans. They would deploy instruments. They would question anomalies. One day in their deep future, they would record the blackout events with precision, and the cycle of observation would begin anew. But that moment was still far away. For now, the shadow passed through the water in complete silence, leaving behind no disturbance. The ocean closed behind it. The world continued to rotate. The universe continued to expand. And somewhere across vast distances, other oceans in other star systems would soon echo the same event. The blackout fields would emerge again and again as long as matter cooled into planets, as long as gravity shaped oceans, as long as the laws of physics remained unchanged. They were not rare in the cosmic sense. They were not anomalies in the universal sense. They were simply part of the quiet library of what water could become under perfect alignment. And so the darkness continued drifting through alien seas, an eternal pattern unfolding across infinite worlds, appearing wherever conditions allowed and vanishing whenever the balance shifted. Waiting always in the mathematics of the cosmos for the next ocean to call it forth. Across the widening span of cosmic time, the blackout fields became a quiet, constant threading through the fabric of planetary oceans, like a repeating motif in an infinite composition. Each reappearance shaped not by chance, but by the inevitability of physics expressed under the correct geometries. As galaxies matured and stellar clusters drifted apart and recombined, as planetary systems collapsed and reformed, oceans continued to gather wherever temperature, pressure, and chemistry allowed. And wherever oceans gathered, the shadow state of water lingered as a latent possibility, waiting patiently for perfect alignment. On a world bathed in violet twilight, from a swollen, aging star, an ocean deeper than any on Earth rolled across a surface etched with broad continent fragments broken by vast rift valleys. Its thermocline lay not at a shallow boundary, but far beneath the surface, a kilometer-thick layer where pressures were immense and temperatures stabilized into a narrow band that oscillated only slightly with planetary rotation. Over centuries, slow tidal forces drawn out by the gravitational pull of two large moons sculpted internal waves of unprecedented magnitude, sweeping across this thermocline like continent-wide pulses. These waves traveled so steadily that their crests maintained coherence for decades, creating vast, traveling pressure ridges that moved through the water as if the entire ocean breathed in slow, synchronized motion. When the first inversion field emerged in that sea, it stretched nearly 2 kilometers across, a colossal drifting expanse of perfect darkness that extinguished the violet glow of the star even at depths where no natural light should have reached. The field glided for weeks across the breadth of the basin, so large that even deep currents were forced to split and detour around its optical boundary. Life in that ocean, adapted to dim conditions, sensed its passage only as a loss of residual photon scatter. Creatures moved aside, disturbed by the sudden absence of faint glimmering cues that normally marked the position of prey and predators. Electroreceptive organisms detected minute electromagnetic fluctuations around the boundary, but could not trace their origin. The shadow moved with complete indifference to biology, governed only by density and resonance. On other worlds, simpler oceans developed the phenomenon in different ways. In a shallow sea on a tidally locked planet, where one hemisphere baked under endless daylight while the other remained frozen in darkness, the terminator zone formed a narrow corridor where strong differential heating created layers of extreme stratification. In this razor-thin band, the inversion fields formed in rapid bursts, appearing and vanishing like pulses of night sliding through the water. Each blackout lasted only seconds, but they formed in rhythmic cascades aligned with tidal kneading from the planet's parent star. These cascades left trails of minute optical changes in the water, similar to the refractive scars once detected in Earth's thermocline long after the phenomenon had faded. In a young system orbiting a stable binary star pair, a gas giant orbited far from the central heat, but its icy moon sustained a deep subsurface ocean heated by tidal flexing. There, beneath kilometers of frozen crust, the water was pressurized to extreme density. In such a world, inversion fields emerged not as drifting shadows, but as stationary columns anchored to locations where geothermal plumes interacted with stratified layers. These vertical pillars of darkness rose from heated vents and remained fixed for months at a time, flickering with internal wave motion but anchored by physical geography. When the planet's orbit carried it through gravitational resonances with neighboring bodies, the pillars collapsed simultaneously, releasing a cascade of microflashes through the ocean before fading into ordinary water. Across these worlds, and countless others, the phenomenon manifested differently each time, yet always within constraints defined by fundamental laws, never random, never chaotic, always appearing when the combined pressures, temperatures, densities, resonance modes, and molecular alignments matched one of the rare solutions encoded in the physics of fluid systems. As time flowed on a cosmic scale, entire galaxies aged into maturity. Stars burned through their fuel and cooled into dwarfs. Oceans evaporated, froze, sublimated, or were lost entirely to stellar winds. Worlds were shattered by impacts or swallowed by expanding suns. Yet the phenomenon persisted wherever oceans were born anew, independent of memory but not independent of structure. The blackout fields were a universal solution, a natural consequence of any water-rich planet capable of hosting internal waves of sufficient coherence. Even as the universe expanded further and cooled into a thinner, quieter state, with energy spread across unimaginable distance. The phenomenon occasionally resurfaced in smaller pockets, narrow lakes under thick atmospheres, pressurized seas beneath crusts of ice, even in rare nebula-bound worlds where water existed only transiently under peculiar combinations of pressure and gravity. The inversion state appeared like a faint whisper of the cosmos, reminding itself of hidden possibilities. But as entropy increased and large-scale structure eroded, the conditions required for the phenomenon became more difficult to achieve. Stratification weakened as geothermal activity declined across old planets. Internal waves diminished in amplitude, oceans shrank, cooled, lost coherence. Even in moons and distant dwarf worlds, where water remained liquid far longer than on terrestrial planets, the intricate interplay of resonance, density, and temperature grew less likely to align. The blackout fields flickered into existence less frequently and for shorter durations. Their range diminished. Their clarity faded. Eventually, they appeared only as brief, localized flashes at the boundaries of thermoclines too thin to sustain them. Then, as ages passed in silence, they vanished entirely from the observable universe, no longer sustained by a cosmos drifting toward thermal equilibrium. Planetary oceans froze into crystalline shells or boiled away into thin atmospheres. Deep seas collapsed under diminishing geothermal flux. The last inversion field manifested in a subsurface ocean beneath a dying star, a small flicker of darkness no larger than the palm of a future creature's hand, forming and dissolving in less than 1,000th of a second. After that, nothing remained capable of generating the optical inversion. Yet the possibility remained encoded forever in the physics governing molecular interaction. Even as the universe approached the faint cold glow of its distant fate, the fundamental constants remained unchanged. The phenomenon was no longer expressed, but it was never erased. Hidden within equations describing water's refractive properties, in the nonlinear mathematics of density waves, in the quantum mechanical structure of molecular bonds, the blackout state waited in perfect stillness. And if someday, in the far future, the universe rekindled itself, collapsed and rebounded, or gave rise to new structures under different conditions, the blackout fields would reappear wherever oceans formed, and internal waves reached harmonics of impossible precision. For even as everything cooled into darkness, the potential for that moving shadow, for that silent, perfect opacity, remained woven into the fabric of every reality, future or past. A phenomenon with no memory and no purpose, continuing eternally as long as oceans exist anywhere in any universe. A darkness not alive yet not lifeless. A movement not of matter, but of possibility. An echo of hidden physics written into water itself, waiting patiently for the next world to call it forth once again. Across the final stretches of cosmological time, when galaxies thinned into pale spirals of scattered stars and the interstellar medium grew cold and diffuse, the phenomenon that had once drifted through the oceans of countless worlds dwindled into near impossibility. Not because its principles had weakened, and not because the physics that permitted it had changed, but because the universe itself no longer produced environments capable of sustaining the complex interplay of density, pressure, heat flow, and molecular alignment necessary for a metastable optical inversion. Yet the blueprint remained. It would remain for as long as the laws governing photons, fluids, and molecular bonds persisted. As space expanded and starlight dimmed, the last generations of stars grew faint. Their planets froze or evaporated, or were tidally stripped into arcs of debris circling hollow, cooling remnants. In these late epochs of cosmic evolution, the number of worlds with liquid oceans dwindled toward zero. A few icy moons buried deep beneath kilometers of frozen crust still held pockets of warm sea sustained by radioactive decay, but even these internal fires faded with time. The universe entered the long era of cooling, the era of slow shadows, the era where complexity gave way to stillness. But before all processes quieted entirely, a single world in a remote aging system persisted longer than most. It orbited a red dwarf star that burned with a slow, steady glow, conserving its fuel across trillions of years. The planet, locked in synchronous rotation, maintained a narrow ribbon of liquid water along its twilight belt. Here, where day and night met in permanent balance, temperatures remained just high enough for a shallow ocean to survive, even as the rest of the universe froze. This ocean was thin and dark, its thermocline shallow, its internal waves weaker than those of younger planets. Yet occasionally, the tidal tug of a distant passing object, a captured rogue planet now spiraling close to the dwarf's gravity, created enough resonance to ripple through the thin water column with delicate precision. These internal waves were the last of their kind anywhere in the universe. And one day, in the dim orange twilight of that ancient world, the conditions aligned. In a stretch of ocean no larger than a small lake, the molecular structure of the water reached a rare symmetry. Pressure, temperature, and density aligned across a filament of internal wave that rolled silently through the gloom. For a fraction of a second, the water shifted into the forbidden optical state that had once produced vast migrating shadows across planetary seas. Light vanished, perfectly, completely, impossibly. There were no divers to witness it, no sensors to measure it, no living beings remained anywhere in the universe capable of perceiving the final blackout. But it occurred. A tiny final inversion field blossomed in the last surviving liquid sea, extinguishing the weak red glow of the dwarf star across a span no wider than a drifting fragment of ice. It moved a few meters along the thermocline, held briefly in the same silent geometry that had once guided immense shadow corridors across young oceans, then dissolved into ordinary water. The final blackout, the last perfect darkness, shaped not by matter, but by alignment. Afterward, the ocean cooled further. The thermocline flattened. The internal waves weakened to nothing. The last liquid water solidified into crystalline stillness. The ancient star dimmed further, sliding toward the long twilight of stellar evolution. And with that, the conditions required for the phenomenon passed from the universe forever. Yet the possibility remained imprinted in the foundation of all things. If the universe were ever reborn or restructured or quantum fluctuated into new existence, if matter and energy returned to new cycles, if oceans formed again under new skies, the phenomenon would wait for them patiently in the proud mathematics that governed reality. The blackout fields did not need memory. They did not need witnesses. They did not need purpose. They were simply one of the hidden expressions of a universe capable of supporting oceans at all. An emergent structure woven into the relationship between light and water and resonance. A reminder that even the calmest seas contain states of matter seldom glimpsed. And so the last darkness passed through the last ocean in complete silence. The universe cooled, the cosmos dimmed. The story ended not with a return nor a revelation, but with a single, perfect moment when all the ancient patterns that had once drifted beneath countless divers across countless worlds repeated themselves one final time. Then the sea froze. The star faded. The universe fell quiet. And the darkness that once moved beneath oceans vanished into the final stillness of cosmic night, where it rested, unchanged, and eternal, waiting only for the next world, the next ocean, the next beginning.
We upload new videos every single day, so make sure to subscribe and turn on the notification bell so you never miss what's next. If you enjoyed this video, don't forget to leave a like, it really helps the channel grow. Tell us in the comments what you'd like to see next. Your ideas might be in our next upload. Thank you so much for watching and for being part of our community. Stay tuned, stay curious, and we'll see you in the next video.